All right, class. Now, since I cannot see you in person, I'm not sure how much is actually sticking in your brain. So, I'm doing this again. Some of you might be bored, but again, I need to hold hands of all my students, right? So, let's play this one more time. Okay, so we do see the axon terminal of a presynaptic neuron, and we also see a postsynaptic neuron. If we have, I'll use pretty colors. If we have sodium coming in, so we have positive charge entering, right? What will happen to the postsynaptic cell if sodium comes in? Will it depolarize or hyperpolarize? If you say depolarize, you are right. Now let's say we have potassium going out. If we have potassium going out, we are losing positivity, right? If we lose positivity, if the postsynaptic cell or the postsynaptic neuron loses positivity, what does it become? Depolarized or hyperpolarized? It gets more negative inside, so it's hyperpolarized. Okay. Let's say we have calcium coming in. What type of charge? Positive. So if calcium comes in, the postsynaptic neuron, will it be depolarized or hyperpolarized? Yes, positive charge entering, depolarized. If we have chloride ions coming in, what will happen to the postsynaptic neuron? Depolarized or hyperpolarized? Hyperpolarized. Okay? All right. Now, listen very, very carefully. So, no matter whether we have sodium coming in, potassium going out, calcium coming in, or chloride coming in, all this depolarization, hyperpolarization that we are looking at in all four cases, the depolarization or hyperpolarization is only happening in the soma or the cell body, right? And also this can also happen in the dendrites. So I want you to understand this depolarization or hyperpolarization can occur in the soma or soma and dendrites. Okay, soma and dendrites. And this is local change in membrane potential, right? So this is, all these are local changes in membrane potential. Do you agree? And this local change in membrane potential is called graded potential. Graded potential. Okay? So this local change in membrane potential in the soma and in the dendrites is called graded potential. Now, I have a question for you. Can graded potential be different in intensity? Let's take the entry of sodium and entry of calcium, for example, where we have depolarization. Okay, let's take number 1 and number 3. So we are looking here and here. Okay. All right. Now, we know that when positive charge enters, the cell is depolarized, right? And this local depolarization is called graded potential. That's fine. Now, let's say we have little bit of sodium coming in. Little bit of sodium. Will you think the cell will be depolarized enough to reach threshold from resting membrane potential? Maybe not. You may need more sodium to come in to reach threshold from resting membrane potential, right? So let's say there is a little bit of sodium coming in. This is resting membrane potential, this is threshold. Potential, threshold. So little sodium come in, you might have this. So obviously you are not reaching threshold. And if you are not reaching threshold, forget about action potential, right? Now let's say you have resting membrane potential threshold. You have, oh, sorry, my bad. This should be like this, okay? Let's say you have resting membrane potential and a lot of sodium. So a lot of sodium coming in. So obviously it will reach threshold, and once threshold hits, you must have an action potential. Does that make sense? So depending on how much positive charge enters the cell, you can either reach threshold, and remember, if you reach threshold, there has to be an action potential. Or maybe the graded potential is not strong enough and you can have just, little bit of positive charge flowing in, small graded potential, and that's it. Okay, you won't get an action potential necessarily. Now, you only get action potential if the postsynaptic neuron is depolarized. So remember, depolarization, so local depolarization will give you an action potential. Now let's take number 2 and number 4 as an example. So in this case, there is also local change in membrane potential. There is graded potential, right, at the dendrite and soma. But we are losing positivity in case of the chloride ions, and in case of potassium ions, we are losing them, right? So the inside is becoming negative. And in case of the chloride ions, the membrane is again getting more negative because chloride is rushing in. So the idea is resting membrane potential and threshold. Now, let's say we have potassium leaking out. So you will have like this. Right? It'll hyperpolarize. Now let's say you have a lot of chloride rushing in. Greater hyperpolarization. In case you get hyperpolarized, will you reach action potential? Will you get an action potential? No. So if you have local hyperpolarization, obviously you are not getting any action potential, right? You have to reach positive 55 to get an action potential. In this case, you are probably moving from negative 70 to negative 90, negative 100. So obviously no action potential in this case. Does that make sense? Okay. Now, another thing. So we understand graded potential. We also understand when it'll depolarize, when it'll hyperpolarize. Okay, good. Now let's do something else. Okay. So we also know that one postsynaptic neuron, there can be 3 talking to it, right? 3. This one, this one, this one. Remember neuronal convergence? So here we have neuronal convergence. Okay. Now let's say the neurotransmitters that are released from this one causes depolarization. The neurotransmitter released from this one causes a little bit of negative charge to trickle in. And then the neurotransmitter released from this one again causes positive entry of positive charge. So the question is, how does the downstream cell or the postsynaptic neuron decide whether it's creating an action potential or not? Well, it goes with the majority. And this is called This is called summation. What is this called? Summation. Okay. So I will talk about a situation. Let's imagine we are in our normal format. I am teaching you physiology in R126, and I have a bottle of water in front of me. I am a downstream neuron. Okay, you guys are upstream neurons, all 64 of you filling out the room. You guys are upstream neurons, and you will give me a command. Now, I am holding the water bottle, and to the count of 3, you will say drink or don't drink. You decide. Now, I will go like this. 1, 2, 3. Shout. Now, some of you will say drink. Some of you will say don't drink, right? So, as a downstream neuron, what will I do? I will think for 2 seconds and I will go with the majority. I will see, okay, most of my students are telling me to drink, so I will drink. The neuron, the postsynaptic neuron does the same thing. It will have conflicting stimulation from multiple upstream neurons, but it does go with the majority. So it will, so at the axon hillock, which is here, at the axon hillock, there all these information, all these graded potentials will be summed up. So these are graded potentials, right? These will be summed up, and sum of all these graded potential, if it's strong enough to reach threshold, the action, if the graded potential is strong enough and reaches threshold, the axon hillock will shoot out an action potential. This is called summation. Another way is that you have this downstream neuron and you have other neurons talking to it. That's fine. But when you have, let's say, only one neuron is firing, and this neuron is causing, let's say, sodium channels to open up. So you have entry of positive charge, right? Now, when you have successive release of neurotransmitter from one neuron only, you have release of neurotransmitter from one neuron only, right? Obviously, there will be no summation. Instead, this is called so when you have only one neuron stimulating the downstream neuron, we will not have any summation, but this is called, right here, what is this called? This is called temporal summation. Sorry, this is also summation, but I just had a brain fart. This is called temporal summation. Temporal summation. And this was spatial summation. Spatial summation when you are adding things up, and temporal summation when there is only trigger from one upstream neuron. Okay, one last thing